Hi guys, this video is on the line segments that happen when you have secants, chords, and tangents in a circle. I'm not gonna lie, I recorded this entire video and then I realized that the microphone wasn't working. So everything on here is already filled out, but I'm gonna go through each example again. But pretty much everything that is in color is something that I drew, basically. It's not what the original problem would have looked like. All right, so you should know the difference between a secant chord, a tangent, a diameter, a radius. You should be able to identify all those things. So the first example, we have two tangents. Here's their point of tangency, and they intersect at the same point outside of the circle. I like to call these like the party hat problems, because to me this looks like a guy or a girl wearing a little party hat. So in these situations, when you have two tangents like that, those two line segments are equal to each other. So you would set up an equation where the A piece equals the B piece. All right, in a picture like this, we originally started with two chords. And one piece of information that you should know is if the chords are equal to each other. And that's what that little blue tick mark means. Those two chords are equal to each other. That means the arcs that are in between the endpoints, those arcs are also equal to each other. So that's why they have two little tick marks on them. If the chords are equal, then those little arcs are equal. All right, a lot of problems like this, you will have a piece of the radius drawn in, and that will be perpendicular to the chord. And a lot of times they tell you the length of the radius, but they don't draw a radius for you. But if you can draw a radius, do you see that little shape that we created? What have we done in the past that had a right angle and we were finding a missing side? Hopefully the Pythagorean theorem is ringing some bells. All right, this is another problem where the Pythagorean theorem is going to come in handy. We have a tangent, and so that line segment piece of the tangent, the radius is perpendicular to where the tangent touches the circle. That's a definition. That's a true fact. So in a lot of pictures like this where you have a radius and a tangent, it's also a Pythagorean theorem problem. All right, then we come to problems that have two chords. They can be diameters. They don't have to be diameters, just any two chords. And basically you see how each chord is separated into two pieces. So the blue one and the pink one are in two pieces. And so this is the rule. This is just something that you're going to have to remember. This is how we do every problem that looks like two chords intersecting. A times B, so multiply the two pieces of the first chord together, equals C times D. So multiply the pieces of the other chord together. All right, and to work that out, you would either just multiply or maybe distribute and solve for whatever piece you're missing. All right, moving over to a tangent and a secant. The tangent is just one piece, and so I've labeled that as A. The secant, however, is in two pieces. There's the piece outside the circle, and then there's the chord piece that is inside the circle. So this is the rule. Every single time you have a tangent and a secant, this is how you do these problems. It's the tangent piece squared. We have to multiply it by itself to kind of balance everything that's going to happen with the secant. So the tangent piece squared is equal to B, which is the outside piece, times B plus C, which is the whole secant. So it's the outside piece times the whole thing. All right, and two secants is basically the same idea. Each secant has an outside and an inside. So the way we set up an equation whenever it's two secants is the outside piece times the whole thing. And in order to figure out the whole, we add the outside piece plus the inside piece. All right, and so we just set up the secant number one, outside times whole, equals the other secant, the outside piece times the whole thing. All right, we're going to cover these examples over the course of several days. So this is a video that you might need to watch more than once. Definitely rewatch this if you didn't copy down every single one of those rules. I would have them all written down on a sheet of paper, kind of just like the formulas that we had for the word problems with compound interest. It would just be easier for you to have a strategy if you take a piece of paper just like this and have all of them shown so that you can kind of get a problem and look at this piece of paper and figure out, okay, well, which picture does this kind of look more similar to? And then figure out what to do from there.